So the next problem from your logarithmic equations guide at work. We have a log form. We want to change that to exponential form, but first get rid of this 2. So remember, this is not a subtraction symbol, okay? That's a negative 2r worked as the number, this being my base and this being my exponent. So I'm going to divide everything by 2. And so now I would end up with log base 7 negative 2r equals 0. Because 0 divided by 2 is 0. 7 to the power of 0 equals negative 2r is this logarithmic equation set up as an exponential equation. So now anything to the 0 power is 1, which will equal negative 2r. And so therefore r would equal negative 1/2. And again, pause is needed. The next problem that I'm going to show you will be number 9. Remember, you can always go to my email to let me know if you need to see other examples, and I will do that daily. In this next problem, we have log base 10 negative m plus 2 equals 4. Notice I said base 10. Remember, if the base is not there, that means that the base is 10. Okay? So therefore, we're going to subtract 2 from both sides first. And we end up with log base 10 negative m equals 2. And so now it's just a straight logarithmic equation that we can change into exponential form. Okay? So now we would have 10 as our base, 2 as our exponent equals negative m. 10 to the second power is 100. So 100 equals negative m, meaning that m equals negative 100. Again, you can pause as needed. Okay. The next problem we'll be going over is number 11. I'll make sure I have plenty of room to work with for this one, as it's going to include a quadratic. So that may excite some of you. So I do have log base 12 on both sides, which hopefully you remember that means that since the bases are the same when we have a log, they just cancel out. And we end up with v squared plus 35 equals negative 12v minus 1. Okay? Let's write this in the quadratic form that's set equal to 0. So we'll end up with v squared plus 12v. And this 35, I can simply add 1 to it, and that will be plus 36 equals 0. And we want to use factoring for math 1, which means we're going to end up with v plus 6 times v plus 6 equals 0. And we want whichever number makes these equal to 0 gives us our solutions. It's a repeat solution, so our only solution is v equals negative 6. And we have 2 examples left. Remember to go to my email or to the discussion board on Canvas in order to ask other questions. And the next one we'll be covering is number 14. It has a natural log. Natural logs work no different from a log. If the natural log is on both sides, the natural log is going to cancel. So we end up with n squared plus 12 equals negative 9n minus 2. only showed you that so that you wouldn't feel that it was more complex because you had a natural log in it. So now we would end up with n squared plus 9n. Then we have 12 plus 2, which makes that 14. Find your factors of 14 and add up to 9, which is going to be 7 and 2. And now we have our solutions. -7 or -2. I have one more question left, one more problem we're going to look at. And that is number 16. Then you'll be able to ask questions from there later through Canvas or email. Do not forget you have a pause button if you feel like this is moving a little bit too fast. Alright, and so now we have log base 10x minus log base 10(2) equals 1. In that situation, that means we want to condense that to 1 log, and subtraction changes to division. I waited for a second as if you were going to actually be able to answer. Alright, so now we have x over 2 equals 1. Change this to exponential form. My base is 10. Remember, when there is no base listed, that means the base is 10 to the first power equals x over 2. That means 10 equals x over 2. Multiply both sides by 2, and x is 20. That concludes your help video for today. Have a great day.
Stop.